Hello students, I would like to introduce you now to the heat capacity ratio apparatus. So I assume you've read the lab manual. We're talking strictly now about how the apparatus works and how you'll carry out the experiment. I want to begin by simply showing you the components of the apparatus. After we do that, walk you through the steps in the experiment. So here you see we have a gas tank. This gas tank happens to be filled with argon. Then right here we have a carboy, which is a big plastic bottle. The gas is going to go into this carboy. That's really the center point of your experiment. We also have a beaker here that we will partly fill with water so that we can measure gas flow. And then over here we have a manometer. The manometer is used for measuring pressure. It's an open manometer on both ends. So the pressure that it registers is the difference between the pressure in here and atmospheric pressure. So remember that. We will have to measure the atmospheric pressure with the barometer. This is filled with dibutyl phthalate, which is much lighter than mercury, much less dense than mercury. So when you convert from millimeters of mercury, when you convert a height here to mercury, you will have to use a conversion factor, and that's all in the manual. So we'll use all of these pieces of equipment, okay? The principle is going to be that we first purge this, which is currently filled with air, with our argon gas, about 15 minutes the very first time. So this is pure argon, or very nearly pure argon. Now you notice these three tubes. It's confusing to look at. One goes to the gas tank, so this fills us with argon. One goes to the manometer so we can measure the pressure, and the other one goes to the water. There are clamps, as you can see, so that we can clamp off the different tubes at different points in the experiment. But we will fill this and then we will isolate it, except we'll keep it in contact with the dibutyl phthalate so we can always be measuring the pressure. We will fill this to a positive pressure, and that will be our P1. We will then raise and lower this, and our intermediate pressure will be atmospheric pressure, and we will then wait. The pressure will equilibrate, and we'll have a final pressure. I'll go through all of that after we do something else. The first thing you should do before you start your experiment is measure the atmospheric pressure with the barometer. There will be a separate video. It'll be really at the end of this video. It's all going to be one thing, but we downloaded it. So I won't show you how to read the barometer, but I want you to show you where it is. So we're going to walk over to the barometer. So here's the barometer. I'll make a couple points about it. There's a thermometer so that you can measure the temperature. The density of mercury depends on the temperature, so you'll want to record that. You will have to fiddle with this knob, which sets the bottom of the measuring scale to the top of the pool of mercury. There's a little cone there, but you're going to see a video about that in detail. And then up at the top here is another knob that will be used to, there's a movable scale right here. This is called the whole app. Together these two scales are called a vernier scale, and you will learn how to read them in the other video that's at the end of this video. So that's a useful thing to know, the vernier, how to read a vernier scale. So there's that. Now, the very first thing I recommend you do after you measure the barometric pressure is to do nothing with gases and nothing with water. Just think through the apparatus and think through the steps. Much better to make mistakes that are only in your mind okay? I also recommend, I recommend you do that though with your fingers a little bit. Go and touch the clamps, try to close them and open them. Make sure you're familiar with how they all operate. So this one, for example, opens and closes right here. To get the best seal, you'll want the tube to be in the middle. See, it's a little hard. I have to twist it here. You want the tube to be in the middle, if you can see. There we go, that'll do. And then as you tighten it, you want this to be horizontal as much as possible. You don't want the tube moving off to the side. You might even want a piece of paper towel to really tighten well when you need to do that. Okay, I'm going to reopen it for now. One critical part of the experiment will be when you have to raise and lower the stopper. So a couple of things about that. I recommend that you practice. After you have a positive pressure in here, you will lift this a couple of inches and replace it. It's just like that. And after you replace it, make sure it's in tight. Okay. Now this motion is important. You want it to be smooth and yet quick. I recommend that the same person do it on each trial of argon. You can maybe switch them for nitrogen. But you want this to be reproducible from run to run, and you need to do 5 successful runs. You will have to establish a positive pressure. One danger is that you wait until equilibrium is established, and 1 second before it's established, this pops out, and the whole run, of course, is ruined because you get a mixing of gases. So keep that as tight as possible. There is a second danger I want to tell you about. You're going to have to establish positive pressure in here. You're going to have this column of dibutyl phthalate up near the top, and if you're not careful, you can shoot it out the top. Now again, if you do that, you set yourself back. It's not tragic because it's not a highly toxic chemical, but you will have to clean it up and then refill the manometer. That sets you back. You can actually see where spills have happened before. I recommend that you think through the whole process, even go through the steps, practice raising and lowering this. Okay. Again, now before we start, I want to talk about the gas regulator. Some of you will have used these before, but some will not have. I will say just a few words, but again, there is going to be a separate video on how to use a gas regulator, so we don't have to take a lot of time right now. But it is very important that you watch that video perhaps a couple of times, be quite confident, although you're never fully confident that you come and do something, because this is gas under high pressure. This is a safe experiment, but if you misuse this, then you can do bad things, shall we say. So let me talk briefly about it. We have the gas tank here. This is argon. This can open and close. There's one valve here. This can open and close. This is a second valve. And this can open and close. That operates a third valve. So we have 3 valves, right? Now, if you can imagine valves 1 and 2, if you can imagine this pressure gauge between valves 1 and 2, you can see that there's a high pressure of the gas in the tank. If you open this, you now have that pressure all the way out to here, and this gauge represents that pressure. That's a high pressure. Between these 2 valves, you have this gauge giving you that pressure. We don't want such a high pressure here. We're in stages lowering the pressure. Then we will work with the lower pressure without all this stuff here. Now, you want to start with the tank closed, and let me see. I'm gonna open this. We've got pressure in here, so I need to be, okay. Okay, so you should begin with the tank closed, righty-tighty, lefty-loosey, right? So righty-tighty, you never want to very much tighten this, but just loosely tighten firm. This is also righty-tighty, and then it's closed. This is different though. When it's all the way out and very easy to manipulate, the valve is actually closed. So it is lefty-loosey, but that's when the valve is closed. These two are righty-tighty, that's when they're closed, so that's different. So the first thing you do is make sure this is a closed valve, but in this case that means this is loose. Open this. Okay. So it looks like we have maybe 5,000 kilopascals. Ask yourself what 1 atmosphere is. It's actually 100 kilopascals. We got plenty of pressure here, right? No problem. Next, make sure this is closed again. You'll want to now righty-tighty turn this in. But now we are opening the valve. But we can open it slowly, and you'll want to watch this left-hand pressure gauge go up. Okay, it doesn't have to move far. And if you see the scale here, we have much less pressure in the left than on the right. Okay, so don't overdo this. You can always open and add more pressure later if you need to. Okay, so I think the first thing you should do is become comfortable with the gas regulator. Once you're comfortable with this, we are now ready to begin the experiment. So I will start the experiment. I will first add water to here. So now the temperature of this water is not critical. Unlike in bomb calorimetry, when you really want it at room temperature, here it really doesn't matter. The amount of water is also not critical, just enough so that you can watch gas bubble. So, now at this point, I'm going to want gas to enter the carboil and purge it. So I'm going to have this clamp open. Simply put that in there and make sure that is tight. It doesn't really matter whether this is open or closed at this point. We're not measuring the pressure. Since you're just working with gases for about the first time, you might want to close it. That will protect you from possibly adding a lot of gas at once with high pressure and shooting the dibutyl phthalate out. So while this doesn't matter, in principle, it might be safer for you to do that. Okay, so we're ready to now put gas, start the purging process. I've already got this to high pressure, this to lower pressure here. I want now to add some gas. I very carefully open this. There. Now, that's about what you want. It doesn't have to be real fast. And now we're going to let this purge for 15 minutes. You shouldn't have it be real fast. We'll empty our argon tank. Have to purchase more argon with state tax dollars, which means your parents or maybe your own. Anyway, so we're going to stop the video. I know unless you'd like to relax and meditate to water bubbling for 15 minutes, you can do that on your own. So we'll stop it and come back in 15 minutes. Okay, so now we have purged for 15 minutes and we're ready to begin our experiment. So I'll tell you what's going to happen, then we'll do it. We're going to stop the gas from flowing, and then we're going to close off the system, so this will be closed. Then we're going to open this, because we'll need to be reading pressures, and then we will establish a positive pressure here. We're going to add a little gas, but be very careful. We don't want to shoot it out. Okay, so now I'm going to close this off, righty-tighty. Gas stopped. So then I'm going to feel comfortable. Well, that was just a little extra left there. I hope. Close this off. Very firmly and tightly, because you want a closed system, right? So you don't want gas escaping from here. Okay. Now, I think that's pretty good, but once again, you want the hose in the middle and this clamp as horizontal as possible so you really get a good fit. So let's see if that worked. Now I'm going to open this a little carefully. Okay, the next thing we want to do is establish positive pressure. This meniscus is going to go up, this will go down, and I'll do that by adding pressure. So this is where you want to be very gradual. I'm going to stop for a second there. This has got to be, you want that in as firmly as possible. Otherwise it could pop off. You want a pretty good high pressure. I'm going to stop it right about there. Okay. Now the gas, when it enters the carboy, is at a slightly cooler temperature than room temperature. So we're now waiting for it to equilibrate. As it warms up. So you'll probably want to wait about a minute for the pressures to equilibrate. Also be able to monitor, the pressures will need to stabilize. If they do not stabilize, if the pressure keeps decreasing, that would be an indication. Think what that might indicate. It probably would indicate there's a leak in the system. So if that's a problem, you'll have to stop and check your system out again. Okay. So we're just going to wait another couple of minutes. I mean seconds, not minutes. So once your minute is up and you've seen that the meniscus has stopped moving, you'll record the top meniscus here and the bottom meniscus, okay, using the ruler here. Now the ruler is graduated in centimeters, so remember you will have to convert to millimeters. We recommend, because the ruler is hard to read, that you take snapshots with your cell phone and then you can blow them up. You can zoom in on a computer and you can read it quite well. It's a little hard to read with the eye, but I've done some tests and it works quite well if you get a good resolution on your cell phone. Okay, so that represents P1 for your calculations. So you'll take the difference in height here, convert to millimeters, then convert from dibutylphthalate to mercury millimeters using the conversion formula, and you'll have to take the difference. You'll have to include the barometric pressure in your calculation. You can think about how to do that. Do you add this to it or do you subtract that from it? You have to think about that. Okay. Then that'll be your P1. What about P2? What do we do next? Next is we're going to raise up the stopper a few inches and lower it. Okay, a rapid but smooth motion and reproducible. So I will show you roughly what to do. That's all there is to it. Now Dennis will pan to the manometer and look what's happening. Okay. So you're going to have to wait about a minute until the pressure stabilizes. Notice that the right meniscus is going up and the left meniscus is going down. That means the pressure in the carboy is actually increasing. Why would that be? You should think about that. There's a physical reason why that's happening. Okay. Once those have stabilized, their minutes up, you simply record the heights of both meniscuses and convert the difference to the pressure by using barometric pressure. That's your P3. Okay. P2 was simply the barometric pressure. Okay. So you have now completed one run of your experiment. You're all finished with one run. You'll finish this by closing off the gas here, and you'll do a second run. In fact, you should do 5 runs on each gas. Exactly what we just did. On the subsequent runs, the purging time can be just 5 minutes. You don't need 15 because this is now almost pure argon with very little air mixed in, just maybe perhaps some up raising and lowering. I recommend doing that 4 more times and you have 5 data points. I recommend doing a quick calculation with a Q-test. See if you should discard 1 data point. If so, you can then do 1 more run and you'll have 5 trials. If you forget, you'll just have to live with 4 trials, I suppose, but it's better to have 5. Okay. That would conclude the experiment. The apparatus should be returned to the condition in which it started. And then, if you're in partners, you can switch. The person doing the observing can now do the run and vice versa, and just do the other gas, nitrogen. Very same procedure, and you'll get then a good 5 data points, we hope, on each of your gases, and that will conclude the experiment. Okay. This will not be the end of the videos. There will be a couple extra videos, one on reading a barometer and one on operating a gas regulator.